So we're going to go ahead and label this Pencast Math 4 number 1. This Pencast is going to be on confidence intervals, how to calculate a confidence interval. And I try not to talk when I'm writing, but as you see me writing, you should be taking notes. All the confidence interval is, it tells you how good your average is, depending if you want to be 90% confident or 92% confident. How good is the average or the estimate that you just made? And we're going to calculate confidence interval. We're going to use the symbol CI for confidence interval. And something else that we're going to be using is confidence level. And for that, I want to write CL so that we're on the same page. When I put CL or CI, you know what I'm talking about. There's 2 types of confidence intervals that you're going to have to write. And we're basically going to make 2 columns here in the notes. We're going to do this for means sampling distributions. Okay, so for a mean sampling distribution, you're going to need your population will have a mu and it will have a sigma. Remember, that's your standard deviation. But your sampling distribution is going to have that mu is the same thing and then sigma sub x bar. You're going to be calculating the mean, the confidence interval. You're going to need to calculate 3 things. You're going to have to calculate your sigma x bar, which is your standard error. I'm going to fit it over here. I'm supposed to write that one first. Your standard error is going to be your standard deviation divided by the square root of your sample size. You're going to have to calculate a z star. And z star is going to be your confidence level. Remember? Confidence level. But it's going to be in decimal form, as a decimal. So if your confidence level is 90%, you're going to write 0.90, basically. 0.90. It's going to be your confidence level divided by 2 plus 0.5. And that's how you're going to calculate your Z. You're going to report your answer like this. My confidence interval, CI, confidence interval, is equal to whatever the mean is. Remember, this is about mean, so it's mu plus or minus the value that you get for C star times the value that you get for the standard error. And this is how you're going to report the answer. And you always say at a given confidence level. So at 90% confidence level or at 95% confidence level. What you need to know is that when you multiply Z star times sigma sub x bar, this is known as the margin of error. So if the question says what is the margin of error, you would take Z star times your sigma sub x bar, you would multiply them, and that would be your margin of error. They're also going to do this for proportion sampling distributions, and these are actually a lot easier than the other one that I'm going to show you. I'm going to give you the equations first, and then I'm going to give you an example of each, okay? Proportion sampling distributions. And these are the types that says how many baseball players are left-handed out of, let's say you have 60 baseball players, how many are left-handed? So let's say 7 are left-handed, your proportion would be 7 out of 60. Or how many people are going to vote for Bush? 20 out of 100 or 80 out of 100, depending if you're Republican or not. you're going to need a proportion. And we're going to call that p hat because it's got this little hat symbol on top of it. And this is basically the part that you're interested in over the size of the sample. So over n. And you just divide those two numbers. You're going to get a fraction there. You're going to have to calculate that standard error, but it's a little bit different. So I'm going to call this one the standard error. And I'm going to call this one sigma, but because it's for proportions, it's sigma sub p hat. And this is how you're going to calculate the standard error for a proportion. Everything under a square root, whatever p hat is, times 1 minus p hat over the sample size. So you do this, and p times 1 minus p divided by n, and then you take the square root, and that should give you the standard error. Z star is going to be the same thing. I don't know why I just put that there. Z star is same thing as before. It's the confidence level as a decimal divided by 2 plus 0.5. Where can I sneak in decimal? That's decimal form. So if it's a 90% confidence level, then it would be 0.9 would be what you would write in there. And you're going to report the answer like this, kind of like before, except you have a proportion that you're reporting, so it's p hat plus or minus z star times the sigma p sub hat that you just calculated. Put this in a box, rectangle, and yes, you always have to say at a given confidence level, okay? And the z times the sigma sub p hat is also known as the margin of error. Alright, so what I'm going to do now is I'm going to show you an example of when you use the mean sampling distribution confidence intervals equations and when you use the proportion confidence interval.